Hello students! So this is part 2. So in this video we're just going to look at a few more examples of factoring out GCFs. Alright, so let's say that we were looking at this example here. My suggestion is to write out the variables with the exponents as repeated multiplication. So here we've got the factors listed out for 15 and the factors listed out for 21. We can say that 3 is the greatest common factor. When we look at the variables, each of these has at least one x in common, and they also have a y in common as well. So when we put all of these greatest common terms, greatest common factors together, now when we look at factoring out this GCF, let's write it. Let's write the original thing, and if we write it out like this, 3xy, and factor out that GCF. So we have to write it with it on the outside. When we look at these little pairs here, the reason why I'm focusing on that particular one is because we're not even using the 1 and the 15 right now. So again, if we take away or factor out those GCFs, or the parts that were in the GCF, if we take away the 3, okay, we can see what's left over. Alright, what's left over on the left in the left term is 5. What's also left over there is the x as far as the variables. And we take out those parts that were in the GCF. Again, what's left over there is just x. And so on the right term, what we wind up having left over is 7. And then when we take out those variables that were inside of the GCF, not only do we have the 7 left over from that right term, but we also have 3 y's left over. So that's y to the 3rd power. Hopefully that makes sense visually for those who may be sort of visual learners. I do hope that does make sense. So let's say that we are looking at this example where we're asked to factor out the GCF and factor completely. So we still want to do like we did in the other examples, where we write out the factors of these numbers. Okay, so when we look at all those factors there, we have some factors that they have in common. So you can see they've got 1 in common. They've also got a 2 in common. And so for the numbers, the constant, the common factor that they have in common there is 2. Each one of these expressions has at least 3 x's in common. So if we put all of the common factors there together, all the greatest common factors there together, we get the GCF is 2x to the 3rd power. Again, if we factor out that GCF, that is 2x to the 3rd, and if we have this written like that, what is left over when we take out or factor out that GCF? Folks, remember that we're only focusing on this pair. We focus on just that pair, or just those pairs of factors, at least with the numbers, those pairs of factors that involve the parts that were in the GCF. And when we take out the 2, which was a part of the GCF, and we take out this 2, which was a part of the GCF, we see what's left over for each part, for each term of that. So from the first term, the number that's left over is 9, right? Because 2 times 9 is what it takes to get to 18, right? And the part that's left over from that second term, and just kind of remember, folks, that this was minus. So what's left over from that, the number part that's left over from that second term is 16. the variables that's left over. So when we take out the variables that were in the GCF, we see what's left over for each of those terms. So in the term on the left, the variables that are left over is 2x's. So that's going to be x squared. It's left over from the first term, right? All right, and then from the second term, okay, if all three of those have gotten taken out, or from the GCF, then there are no variables left in that second term. So, guys, we have factored out the GCF here. But if you listen and pay attention to the instructions there, it says and factor completely. So, what we can do here is we can look at this part right here. That part, it can be factored even more. It can be factored some more. We have talked about something that looks like this. 9x squared is a perfect square, and 16 is a perfect square. And so we have here a difference of squares, and we're going to factor that difference of squares. So when they say factor completely, and like I said, they may not always explicitly say to factor completely, but guys, if you can factor some more, then please do that. Remember that since this is a difference of squares, what we do is we write it out in this particular form, where we identify what A is and what B is. So in this particular form, our A, okay, remember if we take the square root of 9, that gives us 3. And then remember if we divide the exponent by 2, that's how we get x to the first power there. So our A is 3x. And then with the B, okay, the square root of 16 is 4. So our B is 4. So now we use the formula for difference of squares, or the formula for factoring a difference of squares, where that there is supposed to be equal to a plus b times a minus b. The formula for factoring a difference of squares. Okay, so again, we've identified a and b already, and now we just need to use that formula for factoring difference of squares. Remember, guys, that we had already factored out a GCF. That is not going anywhere. We still need to write that GCF when we write out our final version of this. So we're still going to write 2x cubed here on the outside. And now this part here that was a difference of squares is going to be broken down into two more factors. So again, this part here, we were able to factor it further by factoring it as a difference of squares. And again, we're writing it in the form of a plus b times a minus b. And again, we've determined that a is 3x and b is 4. So that's 3x plus 4 and 3x minus 4. That's those two factors of that difference of squares. And this will be our final result here. So we're going to look at one more example here, and then we're going to call it. So let's say that we were looking at this example here, and we were asked to factor completely. Like I said, sometimes they may have like the directions worded a little bit different. Sometimes they may say factor factor out the GCF. Sometimes they may just say factor completely. So if they ever say I guess really with any type of factoring expressions, you should always check to see whether or not there are any GCFs. Because if it is possible to factor out any GCFs, then you should do it, because it's going to make it easier on you. Alright, so in this case right here, again, when we're checking to see if any GCFs can be factored out, in this particular case, it looks like these definitely have a GCF, yeah. Alright, so I know you may be looking like, okay, well, what you mean, Mr. Starkey? Because this first term here that says negative x to the 6, the coefficient there is 1, Mr. Starkey. So what do you mean? Well, yeah, we've already established that 1 is a universal common factor. So if nothing else, we can at least say that 1 here is one of the common factors, right? So if we factor out the 1 there for each one of those, and then we just do what we need to with the variables, then we can figure out what the GCF is. Before we actually look at what the GCF is here, I just kind of want to point out that leading term here, the negative x to the 6th, that's a negative number as the leading term. When you have a negative number as the leading term, you definitely want to include that negative as part of your GCF. So again, guys, since that leading coefficient is negative, then we are going to, or we definitely should, and we are going to include that negative in our GCF. So again, guys, where we had said that again that's negative, right? -1. So there's nothing there. So -1 times 1, but yeah, we don't have to write times 1. Okay, this is the same thing that -13, or sorry, that's +13. But again, if we're taking out -1, then this needs to be -13, right? Because again, if we're including that negative as part of the GCF, that means that we need to think of what the other part of it is. So again, if we're taking -1 out of that, that means that this has to be -30. Okay? So that takes care of the number, right? So we're factoring out the number -1 as part of the GCF. Now, with the variables, each one of those 3 terms has at least 4 terms. It has at least 4 x's in common that can be taken out as part of the GCF. Those common, or the greatest common factors there, we would have negative, and even though technically I don't have to write 1 here, I'm going to write 1. Even though we know if 1 wasn't written, it would be understood that it's a 1 written there. And this is x to the 4th power, right? Because there are 4 x's that they have in common. So the GCF would be negative x to the 4th power. So if we factor out that GCF, the negative x to the 4th power, when we look at what is left over inside of the of this parentheses, again, for this first term, there's no number other than 1 that's left over. So of course that the coefficient that's left over there is 1, and then when we take away these 4 x's, we have 2 x's left. So that's x squared. There we go. X squared. And again, that coefficient there is 1. I'm not going to write the coefficient 1 because we should all know that it's understood that it's 1. Okay. All right. So that's 1x squared. When we take out these other x's, let's see. Okay, we wind up having 1x left over from the second term, and we also have a -13 left over from that second term. So -13, and again we have 1x that's left over. And then from the last term, we have -30 left over, and x. Sorry, actually we have no x's left over from that last term. So when we factor out the GCF there, we wind up having negative x to the fourth on the outside, and then we have x squared minus 13x minus 30. Okay, so guys, I've just changed this original problem. This did say plus, but again I've changed it so that it said minus. Okay, and so we're still taking out the negative 1, but if this, and again I've changed it, so I've got it green. Okay, it now says minus 30x in the original problem, minus 30x to the fourth power. And so if that was the case, then this 30 right here would have been a positive 30 when you take out the negative 1 as the GCF. This would have been positive 30. Okay, and so I am changing this to plus 30. Okay, so that got changed. All right, so when we look at this, because remember we're asked to factor completely, this is something that we can factor, this trinomial. Remember that when we have a quadratic trinomial in standard form, that we can factor it by finding two factors of c. So we need to find two factors of c that add to give us b. Here we're talking about finding two factors of 30 that add to give you negative 13. So the only factors of 30 that will add to give you 13 are these two. Alright, the only thing about that is that they need to add to give you negative 13, right? So that means that these two have to be negative. Negative 3 times negative 10 gives you positive 30. Okay, and when you add negative 3 and negative 10, they give you negative 13. So with us having those factors, we can write out those factors. And so I'm going to go ahead on and bring down that GCF that we already had written, the negative x to the fourth. And remember, we're factoring that trinomial further, that quadratic trinomial further into these two factors here. So that is going to be x minus 3 and x minus 10. That's getting factored into. All right, so I hope that this video has helped you to at least see again how factoring out the GCF could be done. And again, a lot of those problems that you'll do on Delta Math or on Khan Academy could look like these. So yeah. And I know you guys noticed my Obama right there. Yeah, get that education. It's free for you and you and you. God bless America. That's it, y'all.